Okay, welcome to this International Geomorphology Week organized by the International Association of Geomorphologists. And today is the first day. That is why we have kept the inaugural function. And about this International Geomorphology Week, I would request our President, Professor Mauro Soldati from Italy, who will speak on this International Geomorphology Week. Now I am leaving the floor to Professor Mauro Soldati.
Thank you very much, Sunil. Thank you for your participation in this first webinar of the second edition of the International Geomorphology Week. Last year, we had the first edition, which unfortunately was a bit disrupted by the starting of the pandemic. We had two initiatives last year, and it was somehow a kickoff for this event that has become really a great one this year. I am very happy that it is from South and West Asia that this International Week 2021 is starting, because last year there was a very successful event in India, which involved young geomorphologists. And this is also an occasion for me to congratulate on the election as a president and vice president of the group of young geomorphologists of India to Dr. Das and Dr. Roy. I know that this is a very recent event. They have been very active, and we trust that they will continue their activity the same way they did in the past since their start. I would like also to let you know that we are very many attending this International Geomorphology Week. We had already 1,600 registrations for the 11 webinars that are occurring this week. So I invite you to participate also in the webinars that are occurring during the whole week. Very interesting topic, very diverse topic and speakers. I think you will surely enjoy talks given throughout the world. This International Geomorphology Week is certainly giving a great visibility to the IAG and to geomorphology. And I think it will be an important occasion to show more and more the importance of geomorphology for society. And your personal individual contribution, also in terms of participation, will surely enhance this. Besides the 11 webinars organized by the IAG, we have collateral events organized by national scientific members of the IAG all over the world. And I think that at least we can count on another 500 participants within the other events. This very new initiative of the IAG has proved to be very successful. At the beginning, I can tell you that we did not expect such a number of participants, and thus we are very, very happy about that. Of course, our intention is not to substitute such type of initiatives with. We are not intending to substitute our conferences with such initiative, but we've been deprived of our conferences during 2020 and 2021 by the pandemic. So we really thought it was important to be with geomorphologists all over the world through these initiatives. I would like to thank Susan Conway, our president, with portfolio on communication, cooperation, and outreach, for her very important work behind the scenes. She was organizing and liaising with the organizers of all the events, And she did a great job, and her job enabled us to be connected today and during the next days. I would like also to thank the coordinators of the webinars. They did a great job, and it is thanks to them that we will be reaching all parts of the world with our webinars. I would like to let you know that there were decisions taken by the Council of the IEG very recently, and these refer to our regional and international conferences. As you may know, they were postponed, and I can tell you that the regional conference on geomorphology organized by the Iranian colleagues to be held in Mashhad will take place in spring 2022. And our international conference on geomorphology, initially planned for September 2021, has been postponed to September 2022. It will take place in Coimbra. We hope that by that time the pandemic will be over and that we can meet all together there. There will be grants for young geomorphologists to participate in this event, and we will finally be able to be all together on the field, which for geomorphologists is something really very important. So thanks again for your participation. And now I leave the floor to the other speakers. Have a good participation in this webinar.
Thank you, Professor Mauro Soldati, the President of International Association of Geomorphologists. You know, this under the banner of IAG, International Association of Geomorphologists, as one of our missions to promote the young research scholars in different countries, we are very happy to say that outside Europe, I think Australia and India are the two countries, those who have formed these young geomorphologist groups. So for this thing, we get always whole-time support from our headquarters. And that is why our Secretary General, Professor A.R. Siddiqui, from the Department of Geography, Allahabad University, he is with us. He will say a few words about this International Indian Institute of Geomorphologists and its initiatives. Now I leave the floor to Professor A.R. Siddiqui.
Thank you, sir. Thank you, President IAG and Vice President IAG, for giving me an opportunity to say a few words about webinar. On the behalf of Indian Institute of Geomorphologists, I welcome all the dignitaries of International Association of Geomorphologists, speakers, and participants in the international webinar on the occasion of International Geomorphology Week. Since the southern and western Asian part is being organized first, and in India falls in this zone, so as the Secretary General of Indian Institute of Geomorphology, I take the opportunity to say a few words about the Indian Institute of Geomorphologists. The Indian Institute of Geomorphologists was founded by Professor Savinder Singh in the year 1987 in the Department of Geography, University of Allahabad, India. The following objectives were formulated to bring the entire earth scientists dealing with geomorphology and allied discipline on common platform under the banner of IGI, to hold annual conferences in different places of the country, to publish a research journal entitled Indian Journal of Geomorphology, now it is Journal of Indian Geomorphology, to encourage young research scholars during the search in geomorphology by giving awards, and to give more emphasis on research related to human society and welfare of the society. Most of the objectives of the IGI have been fulfilled. Until now, we have organized 32 IGI conferences, which have been organized in different parts of India. I would like to appreciate the effort of IAG Vice President Professor Sunil Kumar Dey for organizing mega event as mentioned by Professor Mauro Soldati, an event of geomorphology that was held in Vigyan Bhavan, New Delhi, that is 9th ICG, during 6 to 11 November in 2017. There were nearly 388 foreign delegates and 178 Indian delegates participated in the conference. IGI also started Young Geomorphological Award of Fellowship for 2 young geomorphologists every year. The steering committee of Young Geomorphology is declared Dr. Shreya Bandyopadhyay as first president of Young Geomorphologists Forum 2020 and Dr. Sayadan Das, vice president of Young Geomorphologists Forum 2020. Young Geomorphologists Forum organized 5 days long intensive training program during 2nd to 5th March 2020 at the Bakhali Island, Kolkata. And there were 70 young geomorphologists from different parts of India have attended this training program. And this was the major achievement of IGI. The theme of training program was present trend of geomorphological researches, writing good research paper in well-recognized journals of the world, quantitative techniques in geomorphology, use of remote sensing and GIS in geomorphology-based and geomorphology-based field excursion also was done. Our Journal of Indian Geomorphology is listed in UGC list. Until now, we have 600 active life members and active geomorphologists in the country. So this was the achievement of Indian Institute of Geomorphology. On the behalf of IGI India, I wish all the success of this international webinar. Thank you very much for giving me a space to say a few words from the IGI platform. Thank you very much, sir.
Thank you, Professor Siddiqui, the Secretary General of the Indian Institute of Geomorphologists, for delivering the activities of the Indian Institute of Geomorphologists. Thank you very much. Now, my co-host, Professor Adel Sefar from Iran. He will welcome all the delegates and will say a few words about the Iranian geomorphology. I will leave the floor to Professor Adel Sefar.
Thank you, Sunil. Do you have my voice?
Yes, you are very much.
Okay. Colleagues, students, professor, and all who are interested in earth sciences and geomorphology from wherever you hear my voice, hello, and I hope you are in health and happiness in these difficult times when the world is affected by the outbreak of COVID-19. These conditions created an opportunity for us to organize an online program for celebrating the Geomorphology Week in the world. And let me send all of the geomorphologists warm greetings from Iran through the window of cyberspace that was supposed to be face-to-face. I would like my special thanks to the President of International Association of Geomorphology, IAG, Professor Mauro Soldati. And thank you very much from Sunil, my friend from India, coordinator of the webinar of South and West of Asia, and all the energetic colleagues and friends on the executive committee of IAG who supported the program of scientific meetings in the field of geomorphology around the world despite the spread of pandemic. Anyway, due to COVID spread, your hosting in Iran to participate in Regional Conference on Geomorphology, RCG, which was to be held in 2020, is postponed to spring 2022 with the agreement of Executive Committee of IAG. And I hope by the time normal conditions will return to the world and our country as well. As you know, geomorphology pays special attention to the face and shape of the earth. And just as our appearance change in the face of various conditions, just as joy, for example, sadness, anger, etc., and represent our mental state, so the face and morph of the earth inform about the energy, state, and development of this only living planet in the universe, and its importance and knowledge are necessary for every decision maker and manager who intends to carry out the project and development, for example, on the land of Earth, For example, without a doubt, just as being away from an angry person is a condition of reason, knowing the faults and energetic points of the earth is a condition of stability for development based on sustainable development strategies. The Geomorphology Week, which started with a webinar in West and South Asia, is needed to say thanks to Sunil from Iran, from India, for his effort to handle this webinar. Is an opportunity to highlight the importance of this knowledge and its role in managing the environment, especially with the development of the world's environmental challenges such as climate change, global warming, should be highlighted for the lovers of this science, especially young researchers in these countries and all of the world as well. Apart from that, today, with the special environmental challenges in the world, attention to landscape change and environmental hazard caused by human behavior and climate change is felt more than ever. In West and South Asia, where the most of the country is located in the arid and semi-world or high-risk coastal areas, for example, this importance is doubled. Access to water resources, severe droughts and floods, population growth, accelerated growth of industrialization and exploitation of natural resources, soil erosion, land degradation, and many land hazards, the importance of paying attention to geomorphological knowledge and studying landscape change in these countries has doubled. For example, in my country, Iran, from one side with more than 75% arid areas and accelerated exploitation of water resources, climate change, and long-term droughts, and other side, natural and environmental hazards are expectable, and the future of nature without pay attention to landscape change and geomorphology science will be dark. As a representative of Iran and a small member of the Geomorphological Society of the World, from here, Iran, a country located in the heart of Middle East, with a world of geological shapes and features from desert to beaches and large mountains, I invite all of you to follow these scientific programs, and I would like to have a special thanks to the IAG team, Mauro, Mihai, Susan, Francesco, and all of my colleagues in EC, particularly Sunil, for all of the support in holding this week and the webinar. And I use from this opportunity to invite all of you to visit Iran in 2020 and experience the landform you have never seen before. Thank you so much again, and enjoy from the webinar. Thank you.
Thank you, Professor Adil Sefar. He is the co-host with me, and he is an executive committee member of the International Association of Geomorphology from Iran. Thank you, Adil.
Thank you, Sunil. Thank you, everyone.
Just I will say a few words, no more than 2 minutes, about this International Geomorphology Week. We had decided in 2019 in executive committee meeting as well as the council meeting in Athens that we will celebrate this International Geomorphology Week in order to promote geomorphological interest among the youngsters, so that the future of this geomorphology can be a bright one. And accordingly, since in the last year, due to this pandemic, as Professor Mauro said, due to this pandemic, it could not be organized in a massive scale. And out of which India and Poland, these two countries organized, and the Young Geomorphologist Group of India, they organized a Young Geomorphologist training program in Kolkata, and we were very happy. We were very happy to see Professor Mauro Soldati to inaugurate that program also through webinar. So this was the achievement from Young Geomorphologist Group, and from South India's geomorphologists are gradually increasing, young stars are coming up, and they are also taking part also in different parts of the world. So,
oui, là, tu vois, c'est l'introduction. Voilà. Celle qui m'a répondu, tu vois, elle parle après les présentations.
So, this was the achievement of the Indian Institute of Geomorphologists. This webinar has meaning, of course, I must thank Professor Shushan Conway, the Vice President of the International Association of Geomorphologists, to take initiative to organize this event in a massive scale and she has divided the whole world in different zones, continent-wise zones, and because there is a very large time gap, it is about 12 hours from west to east. So this is the first one, and I will say on this platform, I will say that this executive committee of the International Association of Geomorphologists is one of the most vibrant EC committee, because this type of organization, annual organization of International Geomorphology Week and its celebration, certainly will have a great impact among the youngsters to come up to this field. So with this few words, I am closing this inaugural function. Now, within 5 minutes, we'll start our lecture sessions, and the first speaker will be Professor Susan Conway. So within 5 minutes, we'll start. Thank you very much for participating in this inaugural function.
Yeah.
Professor Mauro, do you want to say anything?
Professor Sunil. So, hello.
Yes, yes.
Yeah. Just BNGA, you know BNGA, about the BNGA, Bangladesh National Geographical Association. This is the first time we have been included in International Association of Geomorphology. So,
Yes.
would it be possible to announce from your part that we are the, I don't know actually, as a Secretary General of BNGA, so all credits actually you approached us and we have sent the all papers, and from your Executive Committee President Secretary kindly has extended their kind cooperation to include the BNGA as a national member. So it would be really appreciated if you could please announce our name from your part. Okay.
Our president is present here. I think it would be great to announce by the president of IAG.
Yes, president is here, I think.
Yes. So you are talking from Bangladesh, if I'm not wrong. Yes. We are really very glad to have Bangladesh with us. We have welcomed you on our website. Maybe you have seen the welcome there that was posted a few days ago. And actually, there were some contact with Bangladesh also in the past years due to the participation of some young geomorphologists as grant holders in IEG events. We tried to involve Bangladesh as an official national scientific members, but then for some reasons that could not come through. And then also through the intense effort of our Vice President Sunil Kumar there, we established contacts with you, and so finally we were very glad to have Bangladesh within the IEG. Actually, we've been doing an effort since 2017 to involve new national scientific members from countries which were not so active internationally before, but which we were sure they were active in geomorphology within their countries. So this is the effort that we try to do. And the involvement of Bangladesh, Iran, some African countries that did not play an important role within the IG in the past was made. So welcome, and we expect that not only you will be continuing your great work in geomorphology in your country, but that you can export your research outputs and ideas to the whole IEG community in the world. So thank you very much.
So thank you to announce our name, Bangladesh National Geographical Association. Thank you very much. And yes,
Professor Nurul, by this time you will have to send your constitution in English version. And if it takes long time, you can send the Bengali version to me. I will take responsibility to translate it into English. And after that, I will send it to you for approval.
Okay, no problem. I will do my best, yeah.
Yes, welcome, Professor Niki Evelpidou. Welcome. Hi, Niki.
Thank you for this invitation. Hello, everybody, and enjoy the week of geomorphology.
Yes, thank you. By this time, one announcement, one of our former Vice President, Professor Monique Fort, has joined in this program. So on behalf of the organizing committee, I welcome Professor Monique Fort. She is, I think, the senior most in this group.
Thank you very much for that very kind introduction, Sunil. I would like to thank Sunil and Adele as organizers of this webinar for inviting me to present the first lecture. It's a great honor to kick off the International Geomorphology Week 2021. I would also like to thank Mauro Soldati, President of the IAG, and Professor A.R. Siddiqui, Secretary General of the Indian Institute of Geomorphologists, for introducing this webinar and doing the inaugural addresses. Thank you very much. So without further ado, Sunil, if I can take the screen share, if that's possible. I was asked by Sunil to present a little bit about how I actually became a planetary geomorphologist. It's a bit of a strange title after all. And also to reflect on the role of women in both planetary science and geomorphology. And I'm going to do that through a sort of storyline of how I actually got into, and at each point I'm going to reflect on how equality and the role of women has changed both throughout my career and I hope in the future as well. So hopefully that is sharing properly. Let me just check. Yeah, that looks okay. Good. So this is my nice first slide. As Sunil said, what do I do in planetary geomorphology? I look at the landscapes of other planets other than Earth, and this is a beautiful example of an impact crater on Mars with a lovely 3D view. And how did I start in planetary science? Well, I suppose it all started when I was a child. First of all, I got interested in science. So that's the first step in becoming a planetary geomorphologist, I suppose, is to be interested in science and maths, especially if one is going to study the landscapes and the morphometry. So I always wanted to build things. I was interested in Lego and toy cars and building train networks. And at school, I really loved both maths and science and the experiments that we did there. And I suppose that set me apart. I suppose that was from the other girls in my class who didn't really like toy cars. So I suppose even from a youngest age, I was a little bit different from my the girls around me. And from quite early on, this is actually from when I was 16. I did a project on looking at river networks in Cumbria. And this is in the northwestern part of England. I'm getting a bit of background noise here. I don't know who's on the microphone. Aneshwa is got an unclosed microphone. So yeah, as I was saying, as part of my GCSEs, which is in England we take at the age of 16, I actually went out and did fieldwork as part of my geography course, and I actually went and made my own map of the river network in this area. And even I was looking back yesterday, I was even starting to draw long profiles of rivers when I was 16. So this is a good step on the path to geomorphology, that even at 16 I was starting to draw river network profiles. And interestingly here, actually, what you can see is there's some nick points in these rivers, and also there's some plateaus, and these are caused by actually the glacial geomorphology, the inherited glacial geomorphology in this region. I won't go into this now. This is not something I looked at when I was 16, though. So after my school career, actually, I was really inspired by my mum, who was doing a geology degree, in fact, at the Open University. So the Open University allows people to take their degree later on in their life. So my mum was in her 40s, and she actually decided to take a big step and actually do a degree later on in her life. And so she actually decided to study geology, and she really inspired me on her walks out in the countryside. You know, she would pick up a rock and say, oh, well, this tells us about the early history of the Earth and the climate here. So she would point at some old red sandstone and say, oh, look, this shows that England was actually a desert millions and millions of years ago. And I thought this was truly amazing, that just by looking at an outcrop, just by looking at something that looked boring and inert, that you could actually read the history of the Earth, the climate, the animals that were there, and the processes that were going on at the time, just by studying the grains and the fossils of a rock. It just seemed totally amazing to me. So actually at a university, I decided, at Cambridge University, I decided to study earth sciences. I really enjoyed, as you can see here, this is a picture of me on fieldwork after having actually been underneath a debris flow on a coastal field trip in southern England, and you can see the weather is typically very English. I really enjoyed, again, making maps, and then here I've dug out my undergraduate field mapping field map, which actually was in the Crow's Nest Pass in southwestern Alberta, Canada, where actually, as you can see from the title image here, what you're looking at actually is the deposits of the Frank Slide, which is one of the actually one of the landslides that I'm now studying as an analog for Mars, which is quite cool. It brings me back in a circle, back to more than 15 years ago for when I studied in my degree. And at university, I would say that along my other colleagues, you know, I would say we were about 50-50 men and women. I don't think there was a huge difference between the number of men and women studying geology at the time when I did it. But I did notice that, especially when we did fieldwork, there were many fewer women. And actually there was I suppose, not a discouragement for women to participate. We were encouraged to go in the field as well as others, but there were certain constraints, you know, so the boys would go and pee behind a bush, but then where would the women go, and that kind of thing. So it was, you know, it was still a bit of a masculine environment. So at university is where actually I first encountered planetary science as a subject, and actually it was total it was luck, I suppose, because essentially Professor Nick Butterfield, who is a paleontologist at the University of Cambridge, was actually doing a series of lectures on exobiology and detecting life on other planets and the challenges of doing that. And as he was introducing his lecture on looking at biosignatures on other planets, he actually showed some data from the planet Mars. And I was just amazed that we had landscapes on Mars that looked like landscapes on Earth, river valleys, and then landslides, and very much similar landscapes, especially when you look in detail to those that we find on Earth. And I really wanted to know why and how we ended up on a planet that is, to the first order, a pile of craters, actually resembles the Earth in some ways. And that is where it started, and I continued along that way. And in fact, I chose in my master's dissertation at Cambridge to compare Earth and Mars. The inspiration for comparing Earth and Mars was taken from two serendipitous events. First, so my master's project I started in 2003. So the first of those events was the fact that in 2003, the NASA Shuttle Radar Topography mission had just had finished its collection, and the data were being made available online from summer 2003 onwards, tile by tile across the globe. And this was the first good near global topography that we had on Earth available. And this was an incredible resolution of 90 meters per pixel. This doesn't seem very much now, considering we have all sorts of other elevation data sets we can get hold of, but it was for free and it was available to everybody. And you can see the coverage on the bottom left. It didn't cover the polar and areas of Earth, but it covered all other regions with a surprisingly good resolution. So on Mars, we were already ahead of the game, because in 2001, so a couple of years earlier, the global topography at 450 meters per pixel, so not so good resolution, but even so, totally global, had been released as well. So we had the opportunity on both planets to study the terrain and the landscapes at the same kind of resolution using topographic data. So I studied erosional decay of Martian impact craters by using both the global topography on Earth and the global topography on Mars. So these are figures taken from my dissertation project. And essentially what I did is I looked at the database of impact craters on Earth, and I made a topographic study. I looked at their profiles, topographic profiles, radial profiles going from the center out towards the edges, and looked at ways in which impact craters on Earth were degraded by the surface processes that happen on Earth. Unsurprisingly, I found that most impact craters on Earth are degraded by fluvial processes and processes driven by water. On Mars, this is not generally the case. As you can see in the figure on the right, these are impact craters on Mars, but I did find in some cases that the oldest impact craters were actually also degraded by similar erosion processes. And also on Mars, I found that some of the impact craters may have also contained lakes, as do the impact craters on Earth. These weren't new findings, but one of the things I did study in detail on Mars, one of the things I did find, which we didn't find on Earth, was the fact that some of the impact craters on Mars are actually filled with water ice, and which form these big domes, topographic domes inside the impact craters, sort of like mini ice caps. And these are formed around the North Polar. The ones I studied around the North Polar Cap, but they're also found around the South Polar Cap. Mars has two ice caps. This actually resulted 8 years later in a publication that was inspired by my master's work. So it took me a while to finish it after my master's, and you'll see a little bit why in just a minute. So I was very pleased to actually finish this paper 8 years after my master's project. So after I finished my undergraduate master's degree at Cambridge University in 2004, I started work as an environmental consultant with a firm called Arcadis GMI, located in Newmarket, so near Cambridge in the UK. And my job was to use GIS, so geographical information systems such as ArcGIS, to produce maps for the company. And so, for example, one of the things that I did was compile European data. So this is a study that they released several years after I finished, actually quite a few years after I finished, 5 years after I finished. I actually compiled this data for them. And this is a map of surface water features across Europe. I also compiled the groundwater features and all the other things. So I went out and found these data and put them together. And this is to assess the risk posed by petrol filling stations to the water resources in Europe. So that was part of my job. The other part of my job was going out into the field and drilling holes and sampling for pollution. And I have to say that when I was in working in this company environment, I would say that you know, we would maybe had about 30% women in the actual company itself. But when you went out into the field on drilling sites, I was very much the only woman, and you really felt very different as a woman in this kind of environment. Not that I was treated badly, but actually probably I was treated with more respect than actually men would be treated. So I was treated differently, that's for sure. And yeah, I definitely felt that I wasn't possibly as equal as I could be in this kind of environment. So I definitely saw that there were variances between different environments, work environments. Then after I took this job, I actually went back to my passion, which was planetary science, and I took a PhD at the Open University, which is located in Milton Keynes in the UK, and I studied debris flows on Earth and Mars, actually gullies on Mars, which you can see on the right of this slide, and you can see examples of the landforms that I studied on Earth on the left-hand side. And I was awarded this PhD in 2010, and as a result, I was able to publish 4 papers, of which 3 of these were completed more or less within the thesis, and another one a bit later. So these summarize pretty nicely the topics that I touched on during my PhD. I did some work on terrestrial debris flows in northwestern Iceland, where I used topography to estimate, where I used topographic data, so the volume in the debris flows as it progressed down slope to predict the runout and thickness of the deposits of potential future debris flows, which is what you can see in this map here, where darker blue colors indicate thicker debris. I performed simulations in an environmental chamber to try and understand how sediment transport processes driven by water might work on Mars, where the atmospheric temperature and pressure mean that water is actually boiling or freezing. And this is work I've been continuing. I used topographic data both on Earth and Mars to compare gully landforms on Mars to gully landforms on Earth to try and understand the active processes. And essentially this work revealed that gullies on Mars, which you can see on the right here, are similar in some ways to fluvial gully networks, but in other ways to gully networks on Earth dominated by debris flows. And several years later, the introduction part of my PhD culminated in this review paper on Martian gullies, which I've been studying for many, many years now, and essentially summarizes the main open questions, and that is that we still don't know whether these landforms on Mars are actually created by liquid water or not, or whether they're driven by some more exotic process like carbon dioxide sublimation. So I then, next point in my career was that postdocs I did in Nantes, which is on the left. It's an image of my current laboratory in Nantes, and the Open University on the right. And I did a couple of return trips. So I spent 2 years in Nantes in a postdoc, and then another 4 years at the Open University before returning to Nantes in 2015. And in my postdoc work, I continued to study gullies on Mars, and sort of refining the techniques that I did in my PhD, using terrain analysis to better understand the gullies on Mars and compare them not just visually, but using topographic information and the properties of their catchment areas to understand what kind of processes are active in Martian gullies. This is another example as well of serendipity, because as I was using these terrain data on Mars to understand the catchment properties, I actually was able then to look at the mass balance in Martian gullies as well and find out that there's a huge amount of mass missing between the erosion part and the deposit part. And actually, the most likely the missing mass is water ice that has been lost between the two parts of the system. So this starts linking towards the themes in my research now, which is looking at the role of glaciers on Mars as well in surface processes on Mars. I also had the chance to, while studying gullies, I actually, again, as I said before, talking about glacial processes, I actually discovered these deposits of water ice across the mid-latitudes of Mars, which actually mean that the impact craters located in the mid-latitudes of Mars have asymmetric topographic profiles. So they have pole-facing slopes that are systematically shallower than their equator-facing ones, which is what this graph is showing. So in 2015, I did the concours CNRS. So what that means is I took the civil servant entrance exam and passed it. So to do that, you need to submit a research proposal and your CV. You have only 12 minutes to present what you would like to do in the CNRS. This has changed now. They now interview fewer candidates so that people get more time to present their work. 12 minutes of questions. And just to give you an idea, there were 4 positions available in 2015. And for the section, so planetary, Earth and planetary sciences section. And of 69 applicants, 42 were interviewed. So 42 interviews of 12 minutes. That's I feel really sorry for the selection board. And out of those 42, I came in the top 4. So here I am in the CNRS in Nantes, finally. And so I suppose in my postdoc, I didn't really notice that there was much, among my peers, the people I knew, the people of the same career stage as me. I kind of felt that, there were as many women as there were men. I didn't feel I was treated any differently being a woman as a man, especially in the academic environment, compared to the private industry, for example, where I really felt that I was kind of the only woman sometimes. There were the odd meetings where I was, especially more high up meetings for space missions where I felt a bit lonely, but I really felt that my career was supported as much as it would have been by my colleagues and friends as if I'd been a man, as if I'd been a woman. When I entered the CNRS, I did notice immediately a slight drop in the number of women. So for example, I am the only research fellow in my laboratory from the CNRS. All the others are men. And in fact, the CNRS is one of the major employers in France, is actually at around 30% women. However, I should say that the Institute is very aware of this and is promoting very strongly the recruitment of women. And I would say that they've improved their recent recruitment is very equal. They recruit equal numbers of men and women now, but they have a lot of time to catch up because the inequality has been built up over many, many years. And so I think there's a very positive outlook in the CNRS for addressing the issues with inequality between the careers of men and women. And I would say it's pretty typical that the further up the career ladder you go, the fewer and fewer women there are. So for example, fewer women get promoted up to directeur de recherche, which is the next level of researcher in this position. But I think there is moves underway to address that. So what did I propose to the CNRS as my research project? I proposed a planetary science project where I wanted to look at the long-term effect of water on Mars at glacial interglacial timescales. So here I'm already mentioning glaciers. And again, very much focused on topography. What can we read from the topographic data that we have from Mars? And so part of my research shifted a bit to looking at other processes other than liquid water. So looking at carbon dioxide sublimation, because carbon dioxide condenses as a solid on the surface of Mars and sublimates away. And actually this cycle can promote sediment transport. So what have I been doing since I was recruited on this permanent position, research fellow position? Well, this stable job position allowed me to become involved in space missions, such as the European Space Agency's Trace Gas Orbiter mission to Mars, which is currently in orbit. CASIS is the camera on that mission, so it's a color stereo imaging camera. And I'm also involved in the NASA team, the Mars Reconnaissance Orbiter, the HiRISE camera, of which maybe you've seen some images in the news recently from both of these cameras, actually, of the Perseverance landing site in Jezero crater on Mars. Both of these orbiters are involved in both relaying the data from Perseverance, but also taking photographs of the landing site. And so it's been really exciting to be involved in these missions. But a really noticeable thing when you get involved in space missions is that the co-Is, so the co-investigators and principal investigators, are mostly men, and this is even more the case in Europe than it is in America. In NASA, there's a real drive to try to make space missions less masculine, whereas in Europe it really is very much the case that most of the engineering and science teams behind space missions are very, very masculine. So there's a lot of work needs to be done in space in order to make it a little bit more gender equal. So as was mentioned in the introduction given by Sunil, I also had the opportunity in this position to take on some more responsibilities outside my strict field research. I was the animator of the blog for the Planetary Geomorphology of the Month. If you don't know about it, go visit. This is the web address. There's a new image every month, and done by a great colleague of mine, Francis Butcher, who's in Sheffield in the UK, and lots of really exciting stuff on there every month. This gets posted to the Geomorph list as well, if you're not familiar with it. But thanks to that initial involvement with the IAG, I became the vice president and in charge of communication, cooperation, and outreach, which means that I deal with the website and the Twitter and the Facebook. And also, as Mauro mentioned in his introduction, I am also helping the local organizers of the International Conference on Geomorphology, the 10th International Conference on Geomorphology, which will be held in Coimbra in 2022. Here are the new dates. And in closing, what I think I want to say is, I think the IAG, in summary, looking back on my career and the different steps and the different parts of my career, both in private industry, as a postdoc, as a research fellow, I think the IAG has a very important role at an international level to promote diversity in geomorphologists, not just in gender, but in all sorts of other things. As an international body, we can promote national diversity, and I'm really pleased to be here at this webinar, a long way from my home area. And I think from my personal point of view, I think one of the things we need to do is combat our own internal biases to ensure fair representation across the sciences, geosciences, geomorphology, and planetary sciences. And I think as a message to all those young people out there who are thinking of a career in geomorphology or in planetary geomorphology or in sciences in general, I think the most important thing I could take from my talk is to be honest with yourself and with your others, and go ahead and follow that crazy idea. When you saw that lecture from Nick Butterfield on Martian Valley networks, go ahead and do it. Okay, So I'll stop there, and thank you very much for your attention, and enjoy the rest of the program.
Okay. Good evening, everybody. First of all, I would like to thank the organizing committee of South and West Asia, and especially my colleague, Professor Sunil Kemar, and also Professor Adel Sepev for your invitation. Special thanks also to the president of IAG, Professor Mauro Soldati, for supporting all these webinars during this special week for all geomorphologists. I'm really happy and it is my honor to be with you today to celebrate the International Week of Geomorphology. My presentation is about earthquake-driven coastal changes. Globally, coasts are exposed to high vulnerabilities and hazards. The effects of marine and coastal processes on human population were demonstrated by extreme events such as the Indian Ocean tsunami in 2004 or Hurricane Katrina 2005 in the Caribbean. This aerial photo depicts the remains of the Roman harbour at Phalasarna. It is situated at Crete Island, which is the southern part of Greece. And this ancient harbour has been uplifted by 6.6 meters due to an earthquake happened in 365 AD with a magnitude of 8.3. The examples of my talk today are coming from Mediterranean Sea. The Mediterranean is characterized by complex tectonics related to the interaction of three main lithospheric plates, which exposes a wide spectrum of interrelated geodynamic processes. The Aegean Sea, which is located at the eastern part of the Mediterranean, is a unique environment in terms of active geodynamics, plate movements, ongoing geological processes, formation of new relief, and dynamically changing landscapes. It is widely considered by the general public that tsunamis are lacking in the Mediterranean Sea. However, tsunami records suggest that the area has experienced such events in the past. Observations and analysis of past occurrences are the basis for understanding them and for developing models and scenarios to predict future occurrences. Among various historical tsunamogenic earthquakes in the Eastern Mediterranean Sea, the most notable are this one at the western part of Crete, whose tsunami inundated coastal sites in North Africa, Adriatic Sea, Greece and Sicily, and this one also causing widespread damage in the Eastern Mediterranean. Accordingly to Shaw and his colleagues' publication, and a similar event to this one happened in 365 AD may occur every 800 years, with the last one, this one, indicating that the area may be mature for a new major event. Tsunami events are frequently expressed in the stratigraphic record as distinct marker horizons and allow for a multi-proxy reconstruction of their spatial and temporal dimensions and their impact on coastal landscape evolution. The dictation and characterization of tsunami deposits preserved in coastal sediments, provides a long-term record of past earthquakes. Boulders have been widely used to infer tsunami depositions in Mediterranean studies. Such boulders or mega blocks are often found isolated or in groups on the coastal zone, and they bear evidence of their transportation from their original location in the intertidal or subtidal zone. Research on paleo-high energy events is fundamental to understand the coastal responses of tsunami or storm impact, the influence on coastal morphodynamics, and for predicting future events. In this map, you may see the large boulder deposits along Mediterranean. And here is Cyprus Island, which will be discussed in the next slide. Cyprus has a long record of tsunami waves, as you may see in this map, as noted by archaeological and geological records. One of my study areas is Cape Greco, lies at the southeastern part of the island and forms a narrow peninsula. At this site, large boulders exist. These boulders are located between 3 to 5 meters above mean sea level, and you may have an idea of the area from this picture and also from the aerial photo. Fossils had to be selected for radiocarbon to date the high energy event. And as you understand, a centeredness exists regarding the particular fingerprints of tsunamis versus storms. And for this reason, we use various hydrodynamic equations. Some of them are listed here. The boulders may be found sporadically or in groups, as in this area in Cyprus, where we identified almost 300 boulders of variable sizes, with the biggest one about 42 cubic meters. Here you may see some cross sections indicating clearly that the vast majority of the boulders are located at an altitude between 3 to 5 meters above mean sea level. Different scenarios using hydrodynamic equations may be discussed for each cluster in order to identify the wave heights for storm and tsunami capable to transport boulders. What we often do is to use further calculations for comparisons. So at the end, you have scenarios for the minimum storm wave and tsunami wave to trigger the boulder's transportation. The geomorphological context of the study area often suggests the transport scenario for the studied boulders. For example, as you may notice in this picture, near sea level, a well-developed wave-cut notch exists, and it appears that the origin of some boulders is owed to the detachment of the notch roof due to the force of waves. It is important to understand the original site of each boulder. For example, this one is evident that has been turned upside down, and its original location is clearly visible. The same we are doing for the underwater part of our study area through snorkeling, diving, or even through ROV. Here you may see the most important earthquakes and tsunamis to have affected this part of Mediterranean. According to our radiocarbon results, at least 2 high-energy events appear to have impacted Cape Greco. The one of them coincides to the well-known tsunami I mentioned before. Another earthquake-driven coastal changes are uplift or subsidence of coastal zone. There is an excellent sea level indicator showing this kind of coastal zone shifting. I am talking about tidal notches. Tidal notches are undercuttings few centimeters to several meters deep, cut in steep calcareous cliffs at or near sea level. Only few types of sea level indicators may provide information about the way a coastal change took place, for example, gradually or coseismically. The profile of a tidal notch is an excellent sea level indicator and provides information on the duration in which mean sea level remained at the level of the notch vertex. This is the vertex of the notch. And if the notch is emerged or submerged, it gives information on the speed, slow or even sudden, of this emergence or submergence. Different tidal notch profiles resulting from slow or rapid sea level changes in sheltered sites and have been listed for various cases of relative sea level fall and relative sea level rise. I will refer to only some of the types indicated in this picture. The left part of the figure depicts uplift of the coastal zone, while the right one subsidence. For example, type A in this column depicts a rapid subsidence greater than the tidal range, resulted to an underwater notch. Type B in this column, we have two submerged former notches which were preserved after two rapid subsidence events greater than the tidal range. Type C here is a little bit more complicated. We have a rapid subsidence smaller than the tidal range, preceded and followed by a period of a millennium of relative sea level stability, produces a notch higher than the tidal range. There are two vertices, one here and one a little bit above, separated by an undulation. Here is the undulation in the notch profile. And I will stop with type D, which is a gradual, we have a gradual relative sea level rise at a rate smaller than the bioerosion rate, and produces a notch profile much higher than the tidal range, but limited, the inward depth is limited. And as you may understand, we have many more profiles explaining what has happened in each area. For example, you may see these tidal notches from Kefalonia Island in the western part of Greece at the Ionian Sea. The lower tidal notch, together with the lower part of the mushroom-shaped rock, began to develop after the coseismic uplift of the upper notch that occurred between this time period. At its turn, the lower notch was coseismically uplifted in 1953 AD. Therefore, the mean sea level remained at the level of the vertex of the lower notch for this period. And the average inward depth implies an average intertidal bioerosion rate of about 0.6 millimeters per year. So we have also a clear idea of the bioerosion rate of this area. Dating relict fossil shorelines is often difficult, especially when their position is below modern sea level and thus have been subjected to bioerosion by organisms that live in or below the intertidal zone. In this case, we may use additional indicators in the wider area. The best way of dating is to date fossils found at the level of the vertex, as they are highly related to the sea level. Of course, finding a biological indicator that it is datable within the nodes is extremely rare. Here we may see a lithophaga in its position. We used in order to date the uplift of a Boyan Gulf an uplift of 1.7 meters that affected an area of at least 3 kilometers. In this case, at least 7 former shorelines, as you may see here, were found at Central Aegean Sea. We are in the middle of Aegean, in Cyclades, at the depth range, as you may see here. And the vertical sequence of several submerged notches indicates rapid subsidence events because of co-seismic origin. As you may notice from this figure, there are different paleoshore lines that have been dated. How we did that? By combining the morphology of the submerged notches and correlating with the archaeological remains in the area and also stratigraphical data from corings in the nearby lagoon areas. One more recent example, maybe you have heard about the earthquake on 30 of October 2020 with a magnitude of 7 that took place north of Samos Island in eastern Aegean. On Samos, 2 teenagers were killed while returning from school to their home. 9 persons were injured and more than 1,000 buildings were recorded as unsuitable for use. The temblor was far more devastating for Turkey, resulting in more than 100 casualties, more than 1,000 injured persons, and 2 reported buildings collapsed in Izmir. Soon after the main shock, a tsunami was triggered. So my team, just after the earthquake, re-examined the various sea level indicators by comparing our measurements taken in 2015, a few years ago, with the new measurements after this earthquake I mentioned before, in order to understand and quantify the co-seismic movements caused by the recent earthquake and to shed light to the tectonic regime of the area. Based on our findings, we concluded that the island has been co-seismically uplifted, but with different magnitude, as you may notice from the map. The numbers you may see are the different uplift around the island. During the earthquake, the western part has been uplifted for 35 centimeters, and this movement is fading to the east. The southern part was normally known for its subsidence through the submerged tidal notches and submerged antiquities, and but during this event it was uplifted. The remains are still under water. They're still remaining underwater, and all this help us to understand the tectonic activity in this area. So thank you for your attention, and I wish you a happy week of geomorphology. And at this point, I would also like to ask you to excuse me, because I have to leave this wonderful meeting, but there is another webinar starting in a few minutes for Civis Alliances, which is also about geomorphology. Thank you again for inviting me. It is my honor to be here.
Thank you very much, Professor Niki.
Thank you, Professor Sunil, for inviting Nepal Geomorphological Society. I'm very pleased to be here to talk on this research that we are going to, here in Nepal for a long time with my colleagues around the globe. And the work which I will present is not only my work, but a couple of people that I have been working for more than 2 decades in the Nepal Himalaya. And I'm very pleased to be here with Professor Monique Fott. Actually, she inspired me to continue my research on this geomorphological part of the Himalayas. We have been working more than 15, 16 years now, and she's here. I'm very, I want to acknowledge her here. And some of the research which I will present, that she was also involved in this process. So from Professor Niki presentation from sea surface or sea level to the highest part of the world, Mount Everest, which has increased 0.6 meter already this year. So today I'm going to present on this perturbation of Earth surface processes by different geophysical and the meteorological processes in the Nepal Himalaya. So, you see this interesting landslide in the eastern part of Nepal, where people are living actually with the risks without understanding the geomorphological changes or landscape dynamics that is going over there for centuries and years. So people are constructing many infrastructures such as road, hydropowers, and others without considering these large-scale geomorphological changes, or in particularly without understanding the watershed level. So the talk will be on these 4 points. I will try to summarize our work in the Nepal Himalaya in geomorphic studies and co-seismic landslides, and then the monsoon-triggered landslide, how these events are shaping the landscape in the Nepal Himalaya. Probably most of you know this cartoon, the Himalayan cross-section prepared by Tony Hagen, and from south to the north. So the whole Himalayan dynamics and the landscape and the geomorphology is coupled with the rainfall and the monsoon with the different tectonic slices from Indo-Gangetic Plain to the Tibetan Tethys Himalaya. And then if you look on the superficial part from Tarai to the higher Himalayas ranges from, in Nepal Himalaya particularly 70 meters to the top of the world. So these kind of, factors are really controlling the geomorphology over there. If we take as example as India fix, and then you can see the different velocities between Indian plate and Eurasian plate, this kind of movement that is really playing the important role to make seismically active of this Himalaya. But if you look the velocities, the central part of the Himalaya is more active and has a high velocities, and that's why we have lots of recent activities, geomorphological activities or tectonic activities that we are facing in that part. So if we zoom a little bit to the Nepal, here you can see these three divisions ecologically, which is at the bottom is a Tarai, and then the hill, and then the mountains. So these hill and mountains are mostly active, and lots of geomorphological processes are happening over there, and the sediment that generated in this part of this Nepal transported to Tarai, and aggradation takes place, and then people have been facing this flooding problem, and then it reaches up to the India and finally to the Bangladesh. So if we look the history of these events, I will show you some of the past large-scale mass movement that occurred. So here I took the photographs from Professor Dittal in debris flow that occurred in 1993, what we call one of the largest cloud burst in the Nepal Himalaya. You can see this debris flow, the debris, and you can see the scale over here. The people are standing over there, and so you can just imagine the amount of sedimentation or the debris flow event, and many people died because of this event. So similar kind of activities would happen most of the time in this part. The another one in Jure landslide in 2014, which is one of the largest landslide in Asia, where blocked the Sunkosi River, and then later Nepal army blasted and then channelized this. So, but in overnight, it killed more than 150 people, and it changed the whole landscape. But again, the similar example you can take from Langtang Valley that occurred or that happened during 2015 Gorkha earthquake. And you can see the scale is a 500 meter, and all this ice and debris just fell down, and this swept this whole Langtang Valley just a matter of few minutes. And then, you know, these are the really large scale, some of the largest scale events in this part of the world. So let me bring to the Pokhara Valley that we are working there since 2010 with Monique and our colleagues from Potsdam University and GFZ Germany. And here you can see the yellow part is one of the beautiful valley in Nepal, where you can see the different lakes. And you know, in 2012, the rock fall was occurred over here, and then all the debris to slide down to the valley. I'll show you another picture. Here you can see the flood event, and you can see the breeze. Again, you can just, you know, imagine the scale of the flood. So it actually changed the landscape. And just right after the flood, I and other friend like Monique and others, we visited that, and it was really devastating. So it's similar like Uttarakhand, you know, the slide just happened a few weeks before. And here you can see the before. There was a very beautiful picnic spot, but later it just washed away by this kind of large scale events in the Pokhara Valley. So then after, you know, we concentrated our work in the Pokhara Valley for the development of large scale valley development in the Nepal Himalaya. So then our group, you know, this paper was published in Science in 2015. So Swagan Hart and our colleagues, we studied this Pokhara Valley in detail. So some of the work had been done in the past from Monique and other colleagues, but we tried to find out more detail about the geomorphological and what's the, you know, evolution of this Pokhara Valley. And then we visited, you know, from the possible site up to the Setu River to the downstream, and we tried to see this, you know, the cross sections and the columnar sections of this valley. You can see this, you know, the section over here. I'll show you some of the photographs later on. So you see, if you go on very north of the Pokhara Valley, you can see the different terraces of the Setu River. We actually carving the valley on a vast scale, and the tectonic adjustment is really high over there. And if you see this zoom section of this, you know, the terrace of the Pokhara Formation, you can see the poorly sorted material. Somewhere you can see the debris flow deposit, including mud matrix supported, and then you have a basal debris flow unit, and somewhere you can find the poorly sorted material. So this kind of the ground scenario gives you the evolution of this Pokhara Valley. And later, our colleague Amelie, she did her PhD, evolution of Pokhara Valley here, and you can see the different photographs which shows the channel adjustment. You see, this is a bridge just reconstructed just in 2014 or so, and you can see there's already the erosion is taking place. And this is on the southern part of the Pokhara Valley, where you can see the basal member, what we call Ghatsok Formation, which is the oldest one, which is, you know, exists in the northern part of the valley also. But what is important here is that this lower level terrace, upper level terraces, if you see the, you know, the changes in the remote sensing imageries, then you can see this tectonic adjustment is going on, and the erosion rate is very, very high. And you see people are living in this valley, just right near to the edge of this terrace. So, the geomorphology is one part, and then the risks. So I'm just trying to relate geomorphology to the human risks as well. So here, another example, you can see beautiful, the profiles of this Pokhara Valley sediments, and see beautiful mountain, Machapusre, Annapurna. So actually, this is the subcassars where the material come from actually, and develop this Pokhara Valley to the downstream. And here you can see this debris flow and sand and silt. You can see the scale over here. So if you look closer, I will not go to detail, but you can see this kind of different distribution of these sediments in the Pokhara Valley, where you can define the different debris flow deposit environment, or the lacustrine, or fluvial successing processes are going on, or sorry, was there and now currently also is going on in the modern scale and the recent scale. And then we doing this fieldwork in the Pokhara Valley, we try to collect some of the carbon material, and then we try to see the edge of these sediment, and you can see some of the pictures here. The intact leaves are here, and intact logs, soil pockets, organic layers, and then we had a big boulder which we call Vimkali boulder, and then we did the exposure dating to understand the minimum age of this nice boulder from beryllium 10. And when we combine all these radiocarbon edges and others, here you can see these, when you plot this thing in one place, you can see that there's a 3 cluster clearly shows that these edges actually correspond with the large 3 earthquakes that happened in the past. So these are some references. So it shows that the 3 major earthquakes actually contributed to develop or to form the largest scale valley in the Nepal Himalaya. So this is one of the first time that we have done this work to find out the earthquake in sedimentary signature. Not only this, if you look on the large scale rock slide in Sagarmatha, Mount Everest National Park, you can see this moment and flow direction. So actually this whole Himalayan chain is tectonically active and shaping this geomorphological changes in that part. And here you can see another picture where this whole mass is just slided from here to there, and you can see the different the geomorphological map we prepared in that area. So these were some of the past events that occurred and shaped the Nepal Himalaya. So in 2015 we had a big earthquake, and it triggered many co-seismic landslides, more than 19,000 landslides. And here you can see this is the epicenter, and this is the major aftershock. And these dots are actually polygons, the landslides. So you can see this in one direction, what we call earthquake directivity, and that created many landslides. But within this one single, one line towards eastern direction, actually this is controlled by the fault, main central thrust, and then some kind of geomorphological terrain. So after that, we tried to understand, what's the relaxation time of the earthquake in the Nepal Himalaya. So we started our work with colleagues from different part of the globe, especially with German Research Center in Potsdam, with Niels and Christine. I would like to acknowledge here. But let me share some of the fundamental thing. Here, one example from March 2015, the earthquake occurred in Taiwan, what we call Chichi earthquake. And then after the Chichi earthquake, actually it took nearly 5 years for the relaxation time, to settle the mountain. So we didn't know in Nepal Himalaya. So we installed the broadband seismometers and the different sediment, the collection and analysis and other thing. So we are doing that work, and then suddenly in 2016, we had a lake burst in Tibetan part of China, and then it traveled to the Batikosi River and to the downstream, and it shapes the landscape. And this work was published in Science 2018. And here we present the long-hanging discussion in the Himalaya, whether one single event can shape the landscape, or the yearly monsoon or the long year monsoon or the one single event. That was a long-hanging discussion, and we presented some of the evidences here. And these are the camera. You can see that we installed before the flood, and then the camera actually captured the flood event that was occurred in the Batikosi Valley, which is just eastern part of Kathmandu. And here you can see we scan the mountain in subsequent years of monsoons. And then this is from the terrestrial lidar scanner. And you can see this blue color represents the erosion, and the red color denotes the deposition. So you can see here, we all see the bank erosion took place. And to the downstream, if you go on downstream, you can see erosion and the deposition. And if you go on bottom, you can see the similar kind of activities. So, I didn't present all this, but if you are interested, I can send the paper to you later on. So this kind of analysis gives you the picture. Here you can see the channel width in meter, and then the different color represents the different year. And if you see the only 2016, after the flood, it says it changes the river width. So around 30 meter to 41 meter. So that's why the one single event changed the whole landscape. This kind of large scale event that were occurred in history and also occurred in 2016 and might occur in the future to adjust this tectonic adjustment. So if you look on the modern time, the landslide distribution in the Nepal Himalaya, and this is the record from 1971 to 2020, where we have more than 4,000 landslides occurred. And this is the fatality landslides, not the single landslides that didn't kill people. And then we had more than 5,000 people killed. And if you look only in 2020, 297 deaths claiming the highest death toll by the natural hazards in the Nepal Himalaya. So I will show you why this is happening in the Nepal Himalaya. So if you look this picture here, you can clearly see the road construction pattern in the Nepal Himalaya and the consequences. This is from the eastern part of Nepal. This is in central part. This is the Kaligandaki Valley, where you can see these are these buildings, and people, government is expanding this road which connect Pokhara to China. And you can see already there is a slope movement, and there are lots of examples. I'm just taking some of them. And the most, the picture here, you see, they construct the road. They do not care the whole slope. They just cut the slope, and next year monsoon, and then we have a landslide. So these consequences are happening there from the physical geomorphology, meteorological aspects, and the anthropological events also. But if you particularly look in 2020, here you can see this kind of superficial slide or debris flow that happened. And if you look this rainfall pattern using different satellite imagery. This is, you can see this, these debris flow are coincide with the, antecedent rainfall, and then the, large, high amount of precipitation. And then, it was really, really sad for us. So here, I'll show you two pictures where you can see the tectonic adjustment is going on in recent history. In 2006 picture in the Western Nepal, in 2020, and you can see the sedimentation. You can see the sediments in the river, and you can see the road construction before and after. And people are hardly considering this kind of tectonic adjustment and geomorphological processes that happening in that part of the world. And so this is the negative consequences. Another one, which is the very beautiful city in the western part of Nepal, it's called Butwal. And you can see the image from 2003. And if you compare that valley in 2019, you can see people have been already shifted to the river channel. And you can see the sedimentation, which has a very large watershed. And in the monsoon, if you have a very high rainfall, then it creates lots of landslides, and then the sedimentation to the downstream, and then this place will be flooded and people will suffer. So the interaction between the geomorphology, tectonic geomorphology, human geography, and then this anthropological activities are really playing over there, and the risk is increasing year by year, and over the decades we are facing this kind of problems. But what we need to do, this is one of the beautiful picture from the Kaligandaki, one of my favorite place. I did my PhD in Kaligandaki Valley. So looking to south and Nilgiri here. And so we need to preserve our pristine landscape and the environment to understand the geomorphology, human and the landscapes. So these are my coordinates here, my email and my personal web page. Thank you very much. I would love to hear if you have any questions. Thank you very much.
Paleoclimate with reference to cryosphere dynamics in the Changme Khangpu Valley, Sikkim, Himalaya. So far from the morning itself, we have already listened from the delegates that how much important to study the paleo environment for present scenario as well as to predict the future perspective. So in this case, I was so excited to do work on paleoclimate while I was doing post-graduation from Jawaharlal Nehru University, and I got too much inspiration from the work done by Monique Ford, Professor Ford, Lewis Armin, and my teachers, Professor Milap Sharma, Professor Sunil Kumar De, and other recent geomorphologists. And then I started my research work, paleoclimate, using the glaciers as a proxy. So in this regard, as we all know, why understanding of paleoclimate is very important to understand the present nature of climate change, as well as to understand the future projection. Because from the past, researchers have identified that Indus Valley civilization collapsed due to one of the main reasons, that is sudden changes in climate. As well as there is another circumstances, that is abrupt cooling in near basin in western Himalaya that lead to the glacial advances also enforced to migrate this settlement. So therefore, glaciers, we can say, as a barometer of climate change. And glaciers in the Hindu Kush Himalaya are the source of 10 largest river system in Asia and other population. But the importance of glacier studies in different spatial extent in Hindu Kush Himalaya is because since historical period we have found glaciers are behaving different way in different parts of Himalaya. Say in eastern Himalaya, for example, in Sikkim, glaciers are receding very fast. Glaciers are receding more faster in Uttarakhand Himalaya, and while in the other in other way in other place like in Karakoram Himalaya, glaciers are advancing. So therefore, glaciers and glacial landforms have taken here as a proxy for paleoclimate reconstruction. In case of paleoglacier reconstructions or paleoglacier advances, we have found many work from other parts of Himalaya. For example, Borit-Chil glacial stage that was happened from 54 Ka onwards. Then Gulkin 1 glacial stage, 25 Ka onwards. Then Gulkin 2 glacial stage, 18.4 Ka onwards. And on the other hand, in northwest Garhwal Himalaya, it was published that Bhagirathi glacial stage having occurred before 60 Ka. But some researchers argued that this glacial stage was at its peak during the MIS 3. Then we have found sibling glacial advances at 5 Ka. The similar type of work have been also done in Lahul Himalaya. Out of them, one is from Owen et al., Batal stage, then Kulti stage, Sunapani 1, Sunapani 2. When we are approaching towards east, we found some many more, a lot of work on paleoglacier extent. For example, work done by Richards et al. And one of the most important glacial stage here is Pedishi glacial stage, started from 25 Ka. But we found very lack of work done in towards more eastern way, basically within the Sikkim Himalaya, because Sikkim Himalaya totally represents the upper Tista basin, and Tista river is one of the most important tributary of Brahmaputra river basin, and this river basin also has important because it is a transnational tributary because it flows from Sikkim in India to the downwards up to Bangladesh. So by keeping in mind all of these importances of this study area, the proposed study has been carried out with the following objectives, like to reconstruct the past glacial extent within the Changme Khangpu Valley and to identify and assess the paleoclimate changes within the Quaternary period. So this is the study area. The star point indicate the location of the study area of that is Changme Khangpu Valley, and from this figure itself we can get idea that this area has been interacted by the Indian summer monsoon during the summer season and northeast winter monsoon during the winter season. And this is the region encircled by the rectangle is Changme Khangpu Valley, and the glacier represents the Changme Khangpu Glacier. And this glacier terminated at 4,810 meters above sea level. This figure shows the overall pictures you of climate, recent climate in this area, where the climatological station lies at Chungthang, that is nearly 50 kilometers down of this glacier. Now, the study has been carried out initially with the satellite data listed here, and then we have also used the field-based data for verification, and then to collect the samples for sedimentological analysis for dating purposes. So geomorphological mapping initially have been done using the different satellite images, specifically Sentinel 2A, Landsat OLI, SRTM team, and then we also rectified those using the Google Earth platform, and finally we surveyed the field landforms, and after that, to understand the process, how those landforms have been evolved or formed, we did grain size distribution analysis of samples taken from those particular landforms, and then if necessary, then we have done quartz surface topography through ACM. Then finally we reconstructed the Palaeoglacier extent. So after that, when we have already demarcated the Palaeoglacier extent, what we have done, we place those events in a chronological order using the carbon-14 AMS dating. Here I would like to say that we tried with the vessel dating, but due to some constraint with the quartz particles, we did not get the data. And due to the lack of vessel dating and surface exposure dating, we used Smith-Hammond surface exposure measurement to obtain the relative chronology where it is necessary. After that, we calculated the paleo temperature and volume using the two formulas given. Number one is using the lab rate simple formula, and the others given by the Seltzer 1994. Then we have also calculated the paleo volume, and in these cases we need to calculate the paleo ELA, equilibrium line altitude. After that, we have studied the geochemistry of facies for some locations, and here we calculated LOI, CIA, and all of these studies have been done in Jawaharlal Nehru University Environmental Lab and IUAC at New Delhi. Now result. So here we found the enlisted landforms, and the major of them are glacier, water body, lateral frontal moraine, hummocky moraine, strut terraces, and etc. Here we found 4 sets of major moraine. That means those signifies the 4 advances. So in the very beginning, I would like to start with the recent one, and this is a lateral frontal moraine that we signify through the phase 4. Phase 4 lateral frontal moraine lies just adjacent to the glacier. This is the field photo of the Changme Khangpu glacier, basically a debris covered glacier, and this moraine is just lies adjacent to this glacier, having steep proximal part, and we have found juvenile stage of gully development here, and all of those signifies the younger age of the phase 4 moraine. We are trying to date this moraine using the CRN dating, but still we haven't get the data. Then we have also found some proglacial and ice marginal landforms like proglacial ponds, dead ice, ablation valleys, blocked drainage sediments. This is an important signature of the paleoglacial advances and might have been blocked due to the advancement of the last glacial advances. Then we also found phase 3 moraine, and this is a chaotic set of moraine demarcates the another phase of Sikkim glacier advance. And these moraines lies just 1 kilometer from the present snout. These are generally dome shaped and having 3 to 4 meter in height. They constitute boulders having striation marks, and these materials generally comprised of very poorly sorted bouldery, very fine gravelly sandy matrixy. The phase 3 was preceded by terminal moraine phase 2. And phase 2 terminal moraine, this is the well-preserved furthest extension of this glacial limit. And that lies at an elevation between 4,740 to 4,540 meter above sea level, where a strat terrace exists at the end. We found one open section on this moraine, and we studied this moraine. This is the field photograph of this moraine. Here we have found that there is a different type of facies within the glacier, within the moraine, and we can found that there is a ductile formation within ductile formation here signifies the signifies that there was a water there was a water and sudden englacial flow and overriding glacier ice responsible for the formation of such kind of ductile formation. Phase 1 moraine that we also found, but it was eroded down, and we have find its stretch up to Shiv-Mandir Army Camp, and therefore we only restricted our research up to the phase 4 moraine. As we have found, there is a lack of surface exposure dating and vessel dating. Therefore, we relied on relative dating of landforms, particularly on the moraine, phase 3 moraine, then on the paraglacial fan, on terminal moraine, that is phase 2, and on Palaeoclimate valley. We have used here Prosecute DigiSmith 2000 hammer, and finally we plot those measurements on the graph made by Lowe and Walker, and their work was on Mutil Rock Glacier. When we plotted our value over there, we found that the phase 2 terminal moraine age ranges beyond the 10,000 years BP, and when we plot the ages of the ablation valley, we found that ages ranges between 4,000 to 7,000 years before, and the ages of the boulders from phase 3 moraine lies in between 1,800 to 4,000 years before. And from the paraglacial fan itself shows the result lies in between 500 years ago to 1,900 years ago. So this is the furthest extent, or maximum extent of the Changme Khangpu Glacier. We found that this phase was occurred under the impact of minus 1.73 degrees centigrade temperature, lower temperature, when delta ELA was minus 289 meter from the present, and average ELA lies at 4,979 meter above sea level. And during this time, this glacier advances blocked the Ablation Valley drainage and formed Ablation Valley Lake. We dated this sediment. Now sediments only prevail, so we dated this sediment and we found that this lake was started to form before 31.47 Ka Cal-BP and sustained till 27.32 Ka Cal-BP. After that, this glacier was receded back. Some noise. Okay. Receded back and again got advanced at phase 3, when under the impact of minus 0.80 degree centigrade temperature, when delta ELA was minus 133 meter from the present time. And in between these phases, that means glacial advances, that means in between the period, intermediate period, intermediate period, intermediate period between phase 2 and phase 3, this valley experienced a huge debris avalanches from the world, and we have dated those materials, and we found the date was 14.05 K Cal-BP. And after these avalanches, glaciofluvial processes dominated over this slope, and we dated those this sediments also, this glaciofluvial sedimentary archive 2, and we found there is a lot of facies within this archive, and using the help of Moonshell color chart, we defined those facies, and later on we did geochemical analysis to identify the relative humidity changes. And we also did the ACM analysis for some quartz materials from this archive, and this ACM features shows that those are mainly subangular. Secondary microfeatures developed on primary fractures, and we have also found some minor dissolutions. So these all signifies about the fluvial transportation. Now, when we are coming for paleo-environment reconstruction during this interglacial period from this glaciofluvial archive, we found that there is an increase in humidity around 14 Ka Cal-BP to 6.9 or around 7 till 7 Ka. After this period, there is a prolonged dry period from 6.97 Ka to 4.52 Ka. But in between this, there was a sudden peak in humidity. After this period, there was again increase in humidity from 4.52 Ka to 3.45 Ka. So therefore, we can find that humid period in the CKB started around 14 Ka and sustained till 7 Ka Cal-BP. This result is equivalent with the results which have been found from the adjacent valley of Chopta, which also observed about the enhanced ISM between 11 to 6 Ka. And this valley also found the dry phases, experienced millennial scale aridity, since mid-Holocene period. After this phase, that is phase 3, this glacier, okay, so the mid-Holocene, when we are talking about mid-Holocene dry phases, Overbeck had also suggested that southwest monsoon weakened after 5.5 K, and the presence of Tibetan Neolithic groups in Lunana, that is northwest Bhutan Himalaya, also have been found around 6.7 K. So 7 K CalBP. So therefore, dry period in the Changme Khangpu Valley is correlated with the settlement of this Neolithic group in Lunana also, because this this dry period might have forced the migration of these people from Tibet by crossing the high mountain passes. Therefore, around 4.5 K ice and glacier recession provided the accessibility in eastern Himalaya, and the permanent human colonization basically by the Neolithic Yak pastoralists from Tibet was established in northwest Bhutan Himalaya. And after this phase, the Changme Khangpu Glacier has experienced phase 4 advance, when the temperature was much cooler than present day. It was minus 0.56 degree cooler than present time, and delta ELA was minus 94 meter than present time. When glacier was receded back from phase 3, it formed glacial fluvial terraces, and we dated these terraces. We found that terrace was formed at 1316 CalBP. As because of the paucity in beryllium-10 dating or beryllium-10 dating from the moraine, phase 4 moraine, we presume that this phase 4 glacial advance was happened after 1316 CalBP. And this is the present scenario of this glacier, where present ELA lies at 5,268 meter above sea level. So from this we can find that the phase 2 glacial advance was happened around since 32 Ka onwards, 32 Ka to 27 Ka. And during this time, we found, even from the stratigraphical analysis of phase 2 terminal moraine of Sikkim Glacier, also suggested the enhanced glaciofluvial processes within the subglacial environment. Hence, we assume that the enhanced subglacial fluvial activity and increased precipitation in this valley are strongly correlated. Because from this graph itself, we can found that around 32,000 years before, there was a sudden peak. There was a sudden peak in precipitation. The data has been collected from Mamlu Cave in Meghalaya. And then from here, we can also found that at that time, SST in Southern Indian Ocean was much higher, and after that the SST in Southern Indian Ocean was lower down. At the beginning of this phase 2, we can found that pollen concentration was much lower in RM core, and the northern hemispheric insolation was much higher. So From this graph, we can find that at that time, due to the high aridity in Tibetan Mongolian area, and vis-a-vis the high temperature in the southern Indian Ocean, there might have latitudinal pressure gradient, and due to this, the northeast monsoon might have been triggered at that time, and this monsoon might have precipitated the snowfall in Changme Glacier over this valley, and this result might have initiated the phase 2 advances of this glacier. So we can say that this glacier started to advance nearly in the intermediate period between the enhanced Asian monsoon and the cooler climate temperature. Some results, some work have been done by previous researcher in Karakoram, like Boris Chill glacial stage was also happened in between the transition period. And this is the period when we have found humidity in our valley, and this is correlated with the early Holocene period and younger dryas. And phase 4 glacial advances also we have found started after the 1300 Cal BP. This is a graph which represents that selective glacial advances in eastern Himalaya over the longitude. Here we found that when the Changme Glacier was advanced, the maximum advance occurred, that is phase 2. At that time, many other glaciers also advanced, like Guxiang, Bogosong, Langtang, and even younger dryas and early Holocene humid period we have found, and we found in eastern Himalaya many other glaciers have advanced. Smaller advanced have been we can see. And during the mid-Holocene dry period that we have found in our valley, we can find in this valley there is a lack of glacial advance in eastern Himalaya. But CK phase 3 advance was also correlated with some of the glacial advances. And Changme phase 4 advance was correlated with the Kogargru Valley glacial advance, Basong Kuko catchment glacial advance. So we have concluded from the entire study that local glacial maximum as per the existing landforms advance was extensive in the valley of Changme Glacier in a response of combination of cooler temperature and relatively higher precipitation. And therefore, it is a transition period of northern hemispheric insolation maxima and global large glacial maximum. Changme 2 glacial advance blocked the Ablation Valley runoff and formed an Ablation Valley lake that was and water of this lake breached along with the recession of the glacier. Therefore, this glacier advance was followed by interglacial period between the phase 2 and phase 3 advance, and this was associated with enhanced humidity in the CKB that was started around 14 Ka and sustained till 6 Ka Cal BP. After 6 Ka Cal BP, the prolonged dry period condition prevailed in the valley, and following this episode, CK Glacier had 2 more advance for a shorter period. Under the impact of 0.80 degrees centigrade and 0.56 degrees centigrade cooler temperature. And we also found that climate tectonic processes interaction constrain the chronological sequences down valley to strata as well as within the glaciofluvial archive. Thank you so much. I would like to acknowledge the local people from Lachung in Sikkim Himalaya, Sikkim government, and teachers, mentors, researchers, and scientists from Nehu, Northeast Hill University, Jawaharlal Nehru University, and IUAC at New Delhi to carry out this research, because without their helping hand, it is very difficult for me as a woman researcher to do work in a very smooth way in this high terrain. And as a geography background, I learned a lot of things, a lot of research activities, a lot of methodologies from them. And local people taught me how to survive in Eastern Himalayan environment, how to acclimatize at that in this type of environment, because this is totally different from which we have experienced in Western Himalaya. So I really acknowledge their help, and thank you so much again for giving me this platform.
So, very good afternoon. First of all, I would like to say sorry, because at the moment I am in field work now, So, in the afternoon I got break couple of hours to attend this workshop. I am very happy to represent my organization. First of all, the Jahangir University, and the second, the BNGA, Bangladesh National Geographical Association, and to present my previous research work, few findings, sharing with you. Maybe India, Bangladesh, more or less the similar geographic unit. You will find the similarities, most of them. Okay. So, what is the topic? The floodplain sedimentation. We know about the floodplain, we know about the sedimentation, but my intention is that how the physical process impact on the human livelihood or land use pattern. Because the Bangladesh is geographical location. So there are a lot of rivers, 230 rivers of Bangladesh crisscross the Bangladesh, 54 international rivers flowing through the Bangladesh. So our Bangladesh part, most of the landform, actually we say the floodplain, and 12% landform are Pleistocene plus tertiary hill, and 8% are the Pleistocene terrace. So that's why most of the land actually floodplain, contemporary sedimentation and floodplain, and their livelihood, people's livelihood are depend on the flood and floodplain sedimentation pattern. So here is the some photograph and the screen you see. This is the very simple technique, actually, very easy and simple technique. The marker bed installation during flood, and after the flood, how much thickness is the flood sedimentation occurred there, and what are the grain size of the sediment, and how the grain size is counted by the local farmer, and how they decide the agricultural land use, crop selection based on the flood event. Okay, so this is the key things actually. So, what I said, the three major rivers, the Brahmaputra, Jamuna, Ganges, and the Meghna river system. Internationally, it is known as the GBM basin, and in Bangladesh, Brahmaputra, Jamuna in Bangladesh locally named as the Jamuna river. So this my study site is actually situated on the bank of the Brahmaputra, Jamuna river. So this is a schematic diagram, actually floodplain. Near the river, we say active floodplain, natural levee, it is a highland more or less, the young floodplain, back slope, and the mature floodplain and back swamp area. So during the flood, we in Bangladesh, actually, we got two types of flood actually. When the natural levee inundated, overbank inundation got inundated, then we say the large flood, and bonna, in local term we say bonna. I think the Indian community, research community and people, they know the term about, but international community, we can say the flood is a large, the catastrophic event, we say the flood event and Bonna. So the second term is the just locally we say the Barsha. Barsha means just it is inundated, but not hampered in the daily life or cropping pattern and their livelihood. So that types of flood actually we say the Barsha. So each and every year of Bangladesh, actually we got either flood or Bonna or Barsha. That means large flood or normal flood. So Bangladesh, already I have mentioned that 80% of the land of Bangladesh are the floodplain. You see, this is the Bangladesh map, and this is all our area of covered with the floodplain. And this area, the northeastern part and southeastern part of Bangladesh, actually tertiary hills, and these are the Pleistocene trash area. So 70% people on an average, actually, based on the biggest record, we can say 70% of the people, they live on the floodplain. Their livelihood depends on the floodplain. So the land is intensively mainly farmed by agriculture activities. And the flood-borne sediment is the main source of the fertility. So that's why flood is flood event influence their agricultural pattern. So I tried to measure the flood-borne sediment and everything and calculate the grain size and the grain size sediment, people, how do they count, and then I try to integrate with the Bayesian decision support system, how it is worked to make a decision whether they could have the better decision or good decision or bad decision to select a particular crop on the floodplain sediment due to sedimentation. So this is the river system of Bangladesh, and the on and average. So this is the record, actually secondary record. So I would like to jump in this slide. So just a couple of things I would like to mention is here. So here I am actually concentrated here. So people, when a large flood occurs, the floodplain actually the near the natural levee, it is sand dominant. If they got the sand dominant sediment, that means coarse sand, coarser than more than 2 millimeters, then the agriculture crop got hampered. If they got the silt dominant, that means less than 2 mm, 63 mm, that means sand, silt and clay particles, silt dominant particles, then the agriculture crop will be, it is better for agriculture crop dynamics. Okay. So this is the actually more or less the floodplain scenario. When the flood events occur, our household, it got inundated, every year the people lives with the flood like that way. So they are the rural area of the floodplain area. So agricultural land use, agriculture during the flood season, most of the paddy field, it got inundated. So some sugarcane field, it got inundated. The rice field and some jute field, it got inundated here. So some types of vegetation is like Sisbania, it got inundated here. So sedimentation. If we see the flood water color, you see this is a large flood, as a catastrophic flood. Then the water color, turbidity, it indicates the sediment, what type of sediment is coming from there. So another is after the recession of the flood, we can easily see how the agriculture crop damaged. Okay, so this is the impact. We can say if near the channel, river channel, if you got the sedimentation like this way, then the cropping pattern would alter, or they got the different the following season they choose the different crop pattern. So it is in terms of the livelihood of the local people. So this is the area. You see most of the sand dominant. So the jute or Sisbania or Sism, it got actually low field due to the sedimentation. So this is the rice field due to the sedimentary, the silt dominant, then it will be better yield. Okay. So this is another type of just few photograph I am showing you. So this is the natural levee area or the near the channel. You see sand, how the sand is spreading after the flood. If we can measure this sediment type of thickness and the grain size, if we can make a calendar for this area, then obviously the farmer will be benefited. His plot will be used for the particular crop of agriculture crops. Okay. So under the consideration of the background, actually there are few research questions. how is the sediment distributed through the two? I already said that there are two different types of. 2007 was the large flood, and 2008 is the normal flood event here. So this sediment, how it is interact with the sediment, the vegetation types actually trap the sediments. If along the natural levee, if you cultivate or leave it as a buffer strip, the sungrass or the sesbania or sugarcane, then it will automatically filter the sedimentation pattern. Because if you leave the land just 20 meters or something, then the stream of the sugarcane or jute or sungrass, it will trap the sediments to slow down. Firstly, it will slow down the flow pattern. Then it will settle down the coarse grain. Then rest of the hinterland, that means the behind the buffer strip, it will get the fine sediment. So farmers usually what they will do, they usually practice during the monsoon season. Actually, before monsoon, pre-monsoon season, they plant the deep water paddy rice. So deep water paddy rice, stream is very long. So this stream actually can slow down the water flow, and the just a few meters of the paddy field. So it got inundated and filtered the coarse grain sediment. So in this way, so people, another part of the river or natural levee, we see the sungrass. That means in Bangla we say sungrass. In scientific name is the Imperta cylindrica. So this type of grass, if it is lived along the natural levee, so automatically it filters the coarse grain sediment. That means the coarse grain sand sediment. So then the rest of the hinterland, it will get automatically the fine grain sediment. That is really helpful for the farmers to choose the right crop for the right plot of land. So and local farmer, how the local farmer count the sediment, or what are their technique to count the sediments, and what decision actually they can get easily based on the probabilistic model. That was my research. So this is based on this. So I have just set a couple of objectives: the floodplain sedimentation, the spatial and temporal variability, trapping the sediment, and the sediment grain size, and how it is interact with the vegetation support. This is the conceptual framework. So I will not discuss because it will take too time. So if someone have some inquiry, then I can explain it later. So what types of data actually used for this purpose of research? So you see the flood hydraulics data, sediment data, then the vegetation data, plot level information from the field survey. Then this type of data, actually what I did, I calculated, and then I count the conditional probability. Then this conditional probability, based on the conditional probability, I have calculated the inference. Then how it integrate or interrelated or impact on each other, the dependency ratio, actually I have calculated based on this data. So in this is the study area. This is the Brahmaputra Jamuna River, and this is the active floodplain area. So, the Brahmaputra Jamuna River is a very mighty river, very large river in Bangladesh, and almost every year this area actually inundated and got inundated. Even in low monsoon season, it got inundated. Sorry. So my study area. Actually, I have chosen on study area just based on the cadastral. There is a lower unit of the administrative is the Mauja. In Bangla, we say Mauja. So cadastral map I used for the plot level survey, and the natural levy based on the land from survey. So natural levy, back slope, and river area I have calculated with this. So before just pre-monsoon season, I installed the marker bed. It's very simple technique. Maybe someone can ask, why is this technique? Because a lot of techniques actually we know to calculate to measure the sediment over the bank, like marker bed, flood layer, brood horizon, and carbon dating, radionuclides. So lots of techniques. Okay, general climate geomorphologic technique. So, but all these techniques actually, from medium to long term, long record. That means like 100 years, 1,000 years, then that technique will work well. But in Bangladesh, as I said, the floodplain, the people, those who live in the floodplain, they need the contemporary sedimentation pattern. They need to know about the if the large flood, what type of sediment will be settled here in the after the flood season. So they can decide, okay, after the flood, I will cultivate this type of crops. So that's why it is very contemporary sedimentation, like 1 or 2 years. So 1 or 2 years, and the Bangladesh farmers, they don't use too much modern technology. They use most of them are traditional technology. So they don't have enough scientific knowledge as well. So they can't use the too much scientific equipment, sedimentation data or something. So they just know if it is just seeing the color of the sediment, just it's a whitish color, they can take it in hand and they brood it, and automatically they can say, yes, it is sand or silt or clay dominant. So it is the local knowledge actually, farmers. So that's why if they can find the layer or thickness of the sediment of the contemporary 1 or 2 years, then it will be really helpful for them. So that's why I use the very simple technique that without investing or without low cost technology. I can say simply low cost technology, very low cost technology. They can use it with their local equipments. They can measure it easily, and they can easily test it in the local soil research institute department. So it will be helpful for them. So this is the marker bed pre-monsoon, and during the monsoon it is inundated, and after the monsoon, how much thickness is there, and then this sediment actually was taken to analyze the grain size analysis. So these all are hydraulic parameters calculated here, and taking how the flood depth, flood flow, velocity, and the the vegetation cover all are impact or effect on the flood grain size. So these are all the statistical data. So I will not discuss about it on. So my main focus about the the land. In Bangladesh we use this type of actually based on the flood depth. We use the highland, medium highland, lowland, and lowland, very lowland, and bottomland. This type of classification actually, International Agricultural Zone of Bangladesh, FAO 1988. Based on this, we use this index, which land is highland, medium land, lowland. So on the floodplain area, the land of the highland, medium land, lowland, what type of sediment actually they got or deposited based on the large or medium flood. So it will be easy, very easy for the farmer or for the local people or for the researcher to know. They can easily prescribe that, yes, if you got this type of land, then flood event is like that. So you can easily foresee or predict after the flood, you will cultivate this sort of crops. Okay, so this is study area site based on the high, medium, lowland, and very lowland. We local name, second column, we use the local name there, and inundation depth, and the plot, how many number of plots actually inundated or the study area. This is the common land use pattern of the area. So highland actually, used for the settlement purpose, and the medium lowland to lowland is the agricultural land. So we have concern about the medium lowland to very lowland and highland. This area actually sedimentation pattern. So this is the naturally be marker bed, MB for marker bed on. So marker bed installed the two different monsoon season, and they got the velocity. So highest, lowest velocity, and how the velocity is integrated with the or related with the sedimentation pattern. So after having the sedimentation, then we calculate the fine grain sediment using the Coulter counter. So this sediment medium and sand, mostly actually we got the medium to fine grain sediment. So D90 and D50 all are actually very suitable agricultural cropping pattern. So this is the sediment deposition thickness and variation. In the map, you see red mark is the marker bed area. So if this marker bed area actually how much thickness of the sediment and how is the variation each other from the natural levee to the back slope, it is calculated here. So maximum in 2007 in the large flood event year we said we found the centimeter 5.5 centimeter, and the back slope we got the 1.9 centimeter, and in the 2008 is the normal flood year we got the 3.8. That means normal flood and large flood we found the nearly 2 centimeter difference, you see, and here is the nearly 1.4 centimeter difference between the two different flood events. So variation we found calculated like this. The additional 40 sediment trough actually installed to support the main marker bed support. So this is the study area actually how I plotted the. This is the thickness, average thickness, the two different dimensions, the 2007 and 2008. So please allow me to describe this slide actually. So sediment thickness. If we say you see sediment thickness 0.2 centimeter. This area actually study area this side. So farmer, if they find this area and if they know this what type of sediment is here, so automatically they can use the right crops. Otherwise, if they plant or cultivate the rice crop or jute crops, it will not be suitable. So they need to know the thickness and the grain size simultaneously. So this is the area actually. And using the GIS, I have played with how the overall the scenario of the study area integration of the based on the sediment pattern. So this is another slide actually. This is the natural levee back slope, the grain size parameter, particle diameter, how differ from back slope to natural levee to back slope we have found here. So this is the statistical data D50, D90. So this information actually, if we can prescribe to the farmer or send to the farmer through a agriculture extension worker, then they can easily choose the right crop for the right plot of land. This is the another phenomenon. You see natural levee, what type of grass actually vegetation? Is a natural levee mostly I said that sungrass or jute or sugarcane. So if it is during the overwhelming inundation, then obviously it will slow down the natural levee area. The flow will slow down here. In the madgrass, in the second layer, and the back slope is the floating vegetation is here. So this type of bounces of grass actually trap the sediment automatically. That means coarse grain sediment. I'm talking about the only coarse sand, not boulder or pebbles or cobbles. Okay. So because the location of Bangladesh, so Brahmaputra, Jamuna actually the sediment pattern, we got the mainly coarse sand to find silt. Okay. So this is the overall scenario, how the vegetation trap the sediment. Okay. Anything wrong? Okay. This type of sunglass. Okay. This is the trapping pattern. Deep water paddy, I have already said. This is the paddy, you see, deep water paddy, it is still nearly 3 meters, So when the water depth increases, the steam also increases simultaneously. Up to 3 meters, it can tolerate. Jute, sugarcane, Sisbania. So these are the thickness, actually, sediment thickness and grain size all are related with the floodplain vegetation as well. Okay. And the agricultural crop, you see, so during the monsoon, shallow water paddy, deep water paddy, jute, sugarcane, and Sisbania, these sorts of agricultural crops we found here. So these are the statistical data. So it is, I think, it vary with the flood events. Okay. So here another scenario is the land use in hectares. How much is actually due to flood event, due to thickness, and due to the sediment pattern? How the shallow water paddy rise, deep water paddy rise, increase or decrease throughout the year. So this is another agriculture pattern scenario. And this is the sediment distribution of the floods. And this is the terrestrial map for land use pattern, plot level survey we have done, and each plot, what type of crops actually 2007 and what type of crops have been cultivated in the 2008. So then we just converted it according to the and with relation with the sediment pattern. And land use, if we say the coarse grain sediments, obviously it will get the some peanut or sesbania, something this type of crops. So single crop land. And if we want the multiple crop land, obviously we need the fine grain sediment, that means sill dominant sediment. So if you want to sill dominant sediment, obviously we need to filter the. So how can we filter that? The natural levee we should keep in the bunches of grasses or deep water rice or sugarcane or sesbanias, this type of crops, like this way. Okay, this is the scenario actually. So this is the variation of the different polymer particles diameter, and this is the during the how soil fertility increased. If we got the large flood, then obviously this type of blue green algae will not be available. If it's the rainwater, then obviously the blue green algae. So it will be helpful for the fertility of the soil or something. Okay, so this is the average calculation of the two different scenarios, and this is the sediment types forward to expect. Okay, and how people actually calculate that, because they don't have any scientific knowledge. They got the vernacular knowledge, the local knowledge. So they just first of all, after receiving the water, flood water, they just stand on it. If you say like that way, they say, okay, this year we got this type of sediment thickness, and if they cracking, after seeing the cracking, they say if it's cracked, so obviously it is sill dominant or clay dominant, not actually sand. So seeing the color or cracking or vegetation cover, they can easily calculate, or they can easily just predict, not calculate actually, they can enhance what type of sediment is there. And this is the open exploration method, and they can easily say, okay, this layer actually indicates this year, this amount of sediment, and this color it is sand, or this color it is dark color, it is indicate the silt, or very dark color it is clay. So farmer count this type of sediment like this. So what I did actually mainly, first of all, if you from the flood event, if you got the flood thickness of the sediment, take the sample of the sediment, then grain size of the sediment. So thickness, grain size, it all depends on the physical phenomenon, the flood duration, velocity, vegetation, flood depth. So sediment thickness, if you got and sand, silt, clay percentage, then you can say the land use pattern will be like that way. So these variables we can classify into the independent variables and dependent variables. Obviously, land form is the independent, and dependent variable depends on the flood, large or normal flood. Then it will be flood depth, flood duration, velocity, vegetation. It will depend on the land form. Similarly, vegetation density, it will control the flood velocity. So these are the independent, sometimes independence and dependent variables. These variables actually dependency level, we calculate the conditional probability. So this the physical parameters, and this is the human parameters. This is farmer socio-economic, we can say model like that way. So if a farmer, if he's a marginal farmer, then obviously marginal farmer means he has 1 acre, less than 1 acre of land. Obviously he will think that this year flood, whatever flood is it, but I need to cultivate the rice crop to meet my family demands. That means subsistence farmer. So if they are a large farmer or medium farmer, they obviously go for the commercial farming. There are some commercial goods. So depends on the farmer's family size, farm size, and market price of the crops. They can take decision. But if they think that without considering the natural factors or phenomena, then obviously they will not get the optimum yield from the particular plot of the land. So this is the physical model, and this is the farmer socioeconomic model. If we integrate it, so how did I integrate it? The Bayesian, we know there are a lot of probabilistic inference model. So I try to use the Bayesian decision support model. So Bayesian distribution from all these parameters during the flood season I got, then calculated it, and conditional probability. Similarly, the local people, their farm size, family size, market price, their decision, crop selection decision. So they will go for a single crop or double crop or triple crop based on the flooding. These two variables I integrated with the Bayesian decision support system. Actually, this way, then based on the data, then the sensibility of the which particles, which factor sensitivity on, like sediment particles is the sensitivity on. Sediment deposition section is 2, and the vegetation, flood flow, velocity is the 2, and then 3 is the landform. That means directly related land use with the sediment particle size. Then farmer also, farm size, family size, they is the secondary, and the how many crops they will consider depend on the farm size, depend on the family size, depend on the crop market price. They will choose the single crop or double crop. So based, if they have the right information about the sediment particles and they can choose the right crop, then decision would be good decision and they will get the optimum. I have used the graphical user interface, the Huggins software. Then I input it was used for the conditional, all data of the conditional probability, like the sediment particles, crop market price, family size, then back propagation. So the back propagation, how it works, all result is coming here. Actually, it is a conditional probability, depends on what type of data actually I am inserting here, and then the decision will go for good or bad. Finally, I have make a table like that way. You see, the first order dependency order is the sediment and agriculture cropping pattern. 2007, that means is a large flood year. 2008 is the difference, and some square root difference, and sensitivity 1, 2, 3, 4 like that way. So we need to consider about the human decision support system with the physical process. Without this, it will not be possible to get the optimum yield. So if what farmer need? Farmer, obviously they need the for the cultivation or for the agriculture cropping pattern, they need the silt dominant sediment, and if they got the better information about the sediment, then they it would be easy, or it would be better to get the high yield varieties of the from the agriculture crop. And if not, obviously they will be sorry or sorrow. So thank you for listening and welcome comment. It is just a few findings of my long and past previous work. So if you have any query, I would be happy to answer you. Thank you very much for giving me the chance in this occasion. Thank you.
Thank you, Professor Nurul Islam from Jahangirnagar University, Dhaka, for your beautiful presentation. Now, Professor Mihai Micu, he is from the Romanian Academy of Sciences and the Secretary General of the Indian International Association of Geomorphology, will say a few words about this webinar. Professor Mihai, now the stage is to you.
Thank you very much, Sunil. Thank you very much, Adele, dear colleagues from the IAG Executive Committee and participants for actually successfully opening the International Geomorphology Week. We have witnessed a consistent session during which keywords like environmental challenges, young geomorphologists, women researchers, scientists, risk reduction, high risk areas, high mountains were intensely presented. We have witnessed how geomorphology focuses on societal relevant problems, aiming to foster mutual learning among scientists and actors which are outside from the academia. Us, as geomorphologists, prove once more that we can sustain the process of creating solution-oriented know-how, which is socially relevant, which is intertransferable between scientists, the scientific world, and the societal practice. Geomorphic expertise is very important in morphogenetic, in dynamic evaluation. We are not performing only fundamental researches, but also highly applied researches. Systemic geomorphic approach for hazard and risk, ensures exposure, vulnerability, risk evaluations, which thus rely in this way on geomorphic derivatives. Our studies are bridging actually science and society and are proving and providing actually continuous links from processes inventory to risk governance. Through this initiative, and I will conclude with this, through this initiative, I believe that the IEG is ensuring an ethical, transparent, effective dialogue, which is highly beneficial in building resilient and sustainable societies, cultures. Congratulations again to our colleagues who broke the ice, let's say. And in the meantime, we would like to invite you to join also the other webinars, which will be organized throughout this weekend. Thank you again very much, and I wish you a safe and successful Geomorphology week. Thank you very much.